Assalamu alaikum kids. So inshallah in this video we'll talk about one of the type of graphs of motion, which is the distance time graph. But before we start off, we need to define different types of motion. So the very first one is the stationary object or an object at rest. That means that the object is traveling at 0 meters per second. Second is object moving with a constant velocity. Third is object moving with increasing speed. Now, for an object moving at constant velocity, the acceleration is zero, while an object moving with increasing speed means that the acceleration is positive. Then we have an object moving with decreasing speed. So for this one, your acceleration could be negative, or you could just say that you have deceleration or retardation. Now, in our course, you need to remember that we do not discuss acceleration or we do not describe acceleration using the distance time graph. We can only discuss whether the speed is increasing or decreasing, whether the speed is constant, or if an object is at rest. So first, let's talk about an object that's stationary or an object at rest. An object at rest on a distance time graph is represented by a straight horizontal line. Lines could be diagonals as well. For an object at rest, we use a horizontal line. All right, that's something that you need to remember. Let's take a look at this graph. This yellow line right here represents an object that is stationary at its starting point. All right. This blue line right here represents an object that's at rest, but a certain distance away from the starting point. It's not exactly at its starting point. That's the yellow line. The blue line represents an object that is a certain distance or displacement away from the starting point, but it's still stationary. It's at rest. Okay, I hope that made sense. Now, an object moving at constant speed or velocity is essentially represented by a straight line or a straight diagonal line. Now, before, an object at rest was a straight horizontal line. This time around, it's a straight diagonal line. One very important thing to note is that the gradient of a distance time graph represents the speed of an object. So you can use the gradient, you can find out the gradient to find the speed of an object at a particular point during the journey. Now on a graph, we have three objects, object 1, object 2, and object 3. All right. Now the three objects all have straight diagonal lines, means they're all traveling with a constant velocity. But nonetheless, we should be able to differentiate between the three objects. The very first thing that we should be able to tell is that all three objects are traveling at different speeds. Object 1 has the highest gradient, hence it's traveling at the highest speed. Object 2 has a smaller gradient than object 1, hence object 2 is traveling at a slower speed, or we can say that object 1 is traveling at a higher speed than 2. 2 has a greater gradient than 3, hence 2 is traveling at a higher speed than 3. So that's the first thing. So the gradient defines the speed. 1 has the greatest gradient, so hence it's the fastest. 3 has the smallest gradient, hence it's the slowest. Another important thing that you should be able to recognize is that object 1 does not start at the origin. It's starting a certain distance away from the origin. So your object 1 was never at the origin in the first place, while object 2 and 3 started from the origin. So this right here is one more thing that you should be able to describe. For an object with increasing speed, your graph looks like a curve. It should be curving upwards because speed is increasing, hence the gradient should be increasing. So your graph should look something like this. It's important to remember that your graph is going to be curving upwards, means the gradient is going to be increasing. How do we know that? Let's consider this point A right here with a hypothetical gradient of 3. And let's consider this point B right here with a hypothetical gradient of 5. Alright, so we can see that A has a much smaller gradient than B. Hence, A would be traveling much slower than B. B has a higher gradient, hence it's going to be traveling faster. So to conclude this point, on a distance time graph, the gradient is increasing. Alright, so an increasing curve means your gradient is increasing. Hence, your speed must also be increasing. So this curve right here, the upwards curve, represents an increasing gradient and hence an increasing speed. On the other hand, we have an object with decreasing speed. Now, of course, for increasing speed, it was curve upwards. So for decreasing speed, it will be curving downwards with a decreasing gradient. So your graph should look something like this. So let's consider 2 points, A with a gradient of 5 and B with a gradient of 3. So you have got A right here and you've got B right here. Now A must be traveling faster than B. Why? Because A has a gradient of 5 while B has a gradient of 3. A has a larger gradient, hence a higher speed. B has a smaller gradient, hence a lower speed. All right. So to conclude, on a distance time graph, the speed is represented by the gradient. The curve is going downwards, hence the gradient is decreasing, and the speed must be decreasing as well. It's very important to be able to find the distance and the displacement from a graph. All right, so let's take a look at the journey of an object. So this right here is the journey of an object which has traveled certain distances marked on the graph. Now, before you actually try to find out the distance or the displacement, it's important to understand that you should break your graph into certain parts. So in this case, I would break the graph into one. Let's call this A. Let's call this B. Let's call this C. And let's call this D. So you should be breaking your graph in certain number of parts. All right. Once you've done that, let's first find out the distance. All right, so let's just find out the distance first. Now remember that distance is the length of the total path taken. So during A, your object is traveling 17 meters. During B, even though that your object is traveling back from 17 to 10, so a difference of 17 to 10, so that's 7 meters. It's traveling back, but irrespective of the direction it's traveling in, it's still traveling 7 meters, right? So we're going to have to add that. Then during C, your object is traveling from 10 to 29. So the difference 29 minus 10 is 19. And then during D, your object is traveling another 29 meters from 29 to 0. So the distance in this case is going to be 17 plus 7, which is 24, plus 19, which is 43, plus 29, which should be 72. So this right here, the total distance would be 72 meters. And why is it 72 meters? Because it traveled a distance of 17 meters, then 7 meters, then 19 meters, and then 29 meters. So irrespective of whether it's moving forward or backward, all the distances will be added. That's something that you need to remember. As far as the displacement is concerned, for displacement, what we are going to say is your object started at 0 and ends at 0. So the difference between 0 and 0 is what? That's 0 meters. Irrespective of what the journey was, we are just going to look at where the object started and where the object ended. All right. So let's say, for example, let's just for an example's sake, let's mark this P and let's mark this point Q right here. I want to figure out the displacement of P and Q. So let's say, for example, I want to figure out the displacement of P and Q. The displacement of P and Q is going to be simple. The object travels 10 up, then 7 down. 17 up and then 7 back. So you should be able to directly see the difference between the initial and the final position. P is at 0 while Q is at 10. So the displacement must be 10 meters. Now, if I want you to figure out the distance from P to Q, the distance from P to Q would be what? The distance of P and Q. So if your object starts at P and goes to Q, the distance would be how much? The distance would be traveling 10 meters, 17 meters up, and then 7 meters down. So that would be 17 plus 7, hence 24 meters. So you should be able to figure out both the distance and the displacement from a distance time graph. All right, kids, that's going to be it for this video. Inshallah, I'll see you in the next one. Bars out.